Hey everyone! Today, we're diving into the fascinating world of fluid mechanics with a hands-on experiment to visually demonstrate the differences between laminar and turbulent flow. With just a few simple materials, we'll explore how fluids behave under different conditions. Let's get started! For this experiment, you'll need a clear, transparent water tank, brightly colored dye or food coloring, a faucet to control water flow, clear plastic tubing or straws of different diameters, and a stopwatch for measuring flow rates. Let's start with laminar flow. In laminar flow, the fluid moves in smooth, parallel layers with no disruption between them. This usually occurs at low velocities and with a low Reynolds number, typically below 2000. We'll use a narrow tube for this demonstration. By adjusting the flow rate to be low, we'll gently inject the dye at the entrance of the tube. Watch closely as the dye moves through the tube in straight, parallel lines, maintaining distinct layers. This is a perfect example of smooth, orderly motion. As you can see, the dye moves in well-defined, straight lines within the tubing. There's little to no mixing between the dye and the water, which clearly indicates laminar flow. It's smooth, predictable, and orderly. Now, let's move on to turbulent flow. Turbulent flow is characterized by chaotic, irregular motion and occurs at high velocities with a high Reynolds number, typically above 4000. For this demonstration, we'll use the same tube or a slightly wider one. By significantly increasing the flow rate, we'll inject the dye at the entrance of the tube. Notice how the dye disperses quickly, forming swirls and eddies, which indicates irregular, chaotic motion. Here, the dye disperses rapidly, forming visible swirls and eddies. The mixing is vigorous, with the dye spreading throughout the water, which is a clear indication of turbulent flow. It's chaotic and unpredictable. Understanding the differences between laminar and turbulent flow is crucial in fluid mechanics and engineering. Laminar flow, which is smooth and predictable, is essential for precise applications like microfluidics and medical devices. In contrast, turbulent flow, characterized by chaotic mixing, is advantageous for efficient mixing and heat transfer in systems like chemical reactors and vacuumnets. Our simple DIY setup helps visualize these concepts, clearly demonstrating how fluids behave in different flow regimes. I hope you enjoyed this experiment and learned something new about fluid mechanics. Let me know in the comments if you try this at home and share your observations. Thanks for watching and see you next time.